Okay, so today we're going to be looking at and trying to understand one of the most common or more commonly used proofs that shows a triangle has 180 degrees. First thing I want to do is a little bit of a we'll call it a prerequisite, and we're going to revisit what we learned last semester when we talked about two parallel lines cut by a transversal will yield you two congruent angles, alternate interior angles, meaning x will be congruent to x, obviously, and then y will be congruent to y. Angles on alternate sides in between two parallel lines will be congruent in angle measure. This is important when we start to look at a triangle. So let's build our triangle and take a look at that. How is that going to help us? So here we have a triangle, and let's give it measures x, y, and z. That's commonly used. I know some of you guys keep seeing this z here and you're thinking it's a 2, but I try to put a line through it and show you that is a 2. Now what we're going to do is we're going to use the base of this triangle, and we're going to create a line here. We're going to create a line with the base of this triangle. Very important. And then what we're going to do is put a line parallel to that going through we could call this the vertex angle. That's mainly used in isosceles triangles, but we'll use this in the vertex of this angle here. Now mind you that both of these lines are parallel. Now what I can do with that is start to look at these lines as if they were transversal. So let's use this as this line here, and we'll call it transversal 1 here. Now along this transversal, I have my angle y here, which I could say is congruent to this angle here also, and I could call this y as well. So I know that y here and here, these two angles, are congruent. That's my first piece. Now I can look at this other line here. I've got a new purple I've been using here. And we could use this side, or let's use this side of the triangle here, this side here, as our second transversal. We'll call it transversal 2. And from that, if two parallel lines are cut by a transversal, then their alternate interior angles are congruent. That's your statement there. And then we could say this angle here, angle Z would be congruent here. Now, the key piece here is to start to look at, well, what are we building here? Well, I could start to see that this X, Y, and Z, these three angles here, are not forming a linear pair, but maybe we could call it a linear trio. Well, what does that mean? Well, if I have a straight line, and I know a straight line is made up of 180 degrees because it's basically cutting a circle in half, we could say, right? Then I know that this X, Y, and Z I have is going to be equal to 180. So if I see that these three angles, X, Y, and Z here, form a linear trio, let's say, they make up a straight line, then I know that's 180 degrees. Well, I've just proven right here with this linear pair and these that X plus Y plus Z is in fact equal to 180. And we see that here I have the y and here I have the y. So whatever y is here will be the same here, and whatever z was here will be the same here. So the angles inside the triangle, x, y, and z, would have to by rule also equal 180. So this is a cool little proof using parallel lines and transversals, which basically takes your two angles, or let's say base angles, and then through alternate interior angles, alternate interior angles forms a line, or we'll just say, just for fun, a linear trio. And because of that, we know that these three angles have to equal up to 180 degrees. This is probably one of my favorite proofs, because it's simple. It's something we used in the previous semester, and it's something that you can easily kind of remember just by working through it and putting the pieces together. So I hope this helps, and you will be, responsible for showing this to me.